You'll notice the trachea is kind of the bottom piece of the larynx, and that's going to divide us eventually into the two lungs. We say the trachea is a patent or open airway because those C rings of cartilage actually keep this thing standing wide open. If you go to Lowe's or Home Depot or one of those stores where they have those corrugated pipes with rings all down the structure, that's exactly how the trachea looks, with one exception. Instead of being rings all the way around, the rings are only on the front and the sides of the trachea.
Is the cat the same way?
Cat's the same way, yeah.
Because when you felt it, it pushed back out.
Maybe I should rip it out. You can cut it out and take a look at it if you like.
Cool.
Yeah. Go ahead, you're going to be in the dumpster in May anyway.
Now we took the heart out, might as well take the trachea.
Take it out. If you would like also, we're off topic, but if you want also, bring a straw to lab. Kevin may have some in there for you. Stick it down into the trachea and blow. Don't suck. And then you can see the lungs inflate. Really, make him do it. That's what you do. But yeah, get a straw, make a slit, and blow. So, it's really cool.
Do that today.
Put him up to it, right, Gary? What's that? Yeah, it's really cool to see the lungs inflate. Okay. Trachea info starts from the top of page 75, so let's take a look there. The trachea is approximately a 4-inch long tube. We call it the windpipe for short. And essentially we're now just transporting air down into the respiratory passageway. At the point of the epiglottis and the larynx is where we made the decision to shunt food into the esophagus or let air travel, of course, into the respiratory system. So now we're strictly dealing with an air-only passageway. You'll notice that about 4 inches down, this is going to divide into a left and a right bronchus. The division point there is called the carina. Kind of sounds like the marina, doesn't it? So that's kind of the point at which your left and right bronchi are going to split off from the trachea. I did want to draw your attention to the info on the worksheet, third bullet point down. What we're noticing now is that we have a lining for this respiratory passageway that's covered with ciliated cells. We also are looking at goblet cells as well because goblet cells produce what? Mucus. Good. We also have pseudostratified epithelial tissue here. Which direction do you think these cilia are pushing their contaminated mucus? Up. Up. Yeah. So the nasal cavity is pushing stuff back so you can swallow it, while the cilia in that trachea are pushing contaminated mucus up. You have the choice to either cough it out and get rid of it, spit it out and get rid of it, or swallow it. So that contaminated mucus does not belong in your lung cavity because that's where infections can set in. So get it up and out so we can get it out of the respiratory passageway.
So that's where phlegm comes from?
That's where phlegm comes from. I think we all probably have it from the pollen right now, so yeah, that's what's going on. Alright, so the whole job of the trachea is to conduct air down into the respiratory passageways that enter the lungs. So you'll notice under stress, there under the physiology, the sympathetic nervous system can actually change the diameter of that trachea and those bronchial passageways. Or under parasympathetic activity, you can actually cause those passageways to constrict. So, you know, our bodies can actually increase airflow into the lungs or decrease airflow. Let's stop and think about that for just a minute because this is kind of different from what we've discussed in terms of the blood vessels. Let's take parasympathetic activity first. Parasympathetic activity is rest and digest. When you're resting and digesting, your heart rate's lowered, your blood pressure's lowered, and your breathing rate is also lowered. Okay, so that means we don't need such a demand of oxygen coming into our respiratory passageways. So you'll notice there during parasympathetic control, the passageways here actually constrict. We don't need that much oxygen right now. We're operating at rest. All of a sudden, somebody scares you to death. You're in fight or flight response. That trachea now will expand or dilate because what do we need more of? Oxygen. So during sympathetic control, you'll notice that the trachea actually dilates to let more air travel into and out of your respiratory structures down below. So it's opposite what we saw with the vessels. But you can see here that it's depending on supply of oxygen coming in.
During anaphylactic shock, is it not, the trachea is not having any effect, it's just the swelling pushing on the trachea?
It's probably the swelling, the excess fluid that's going into the surrounding cells and tissues. So even though the trachea itself may be trying to dilate, the actual lining there is probably swollen with fluid.
Okay.
So it's that edema that's making it hard to breathe.
Okay.
Yeah. Julie.
Is part of the reason that it constricts it to eliminate some of the pressure to make it easier to digest? You know what I mean? Like if you're not breathing as much, then the reciprocity is much pressure. Parasympathetic is all about digestion.
Exactly. That makes sense because you're focusing more on the abdominal pelvic cavity than the activities of the thoracic cavity. That makes good sense. Alright, so at the carina, we're going to split you off into a left primary bronchus and a right primary bronchus. Notice the difference in size here because they're not exactly symmetrical. For just a moment, think back to how the heart is oriented. The pointy portion of the heart, the apex, is situated towards your left hip. And notice that we actually have a longer, more narrow left primary bronchus. Notice the right primary bronchus tends to be wider and shorter. So interesting that we don't have symmetrical sizes here for left and right primary bronchus. What that means is if you happen to aspirate or inhale food down into your lungs, guess which bronchus gets stuck?
The right side.
The right side. The right side is wider and shorter, so the right side will take a piece of hot dog, for instance, and wedge it right into that right primary bronchus. They talked about a year or so ago about actually changing the shape of hot dogs because little kids got them sucked into their lungs. It acts as a perfect seal on that right primary bronchus. So of course if you can't breathe, then no oxygen, and then of course death can be a problem there for that. But if you aspirate something into the lungs, one way to get it out is through what?
Heimlich maneuver.
Heimlich maneuver. If you can't cough it out, have somebody Heimlich you and push that air in your lungs against that obstruction and then push it out of the cavity.
What shape are they going to make them?
They're talking about
Squares?
making them round like bologna.
Hot dog?
Yeah.
That's not a hot dog.
I know, it's not a hot dog.
It's a hot burger.
It's a hot burger, yeah.
That is one of the top 5
Somebody put it on.
fatalities in state children by hot dogs.
Yeah.
That's one of the top 5 real serious, dangerous things for children.
Oh, yeah, the
Death.
chop them really tiny, get them. Yeah.
I know, you used to crumble them.
I mean, meat crumble.
Give them bologna, it's the
I
same
know,
thing.
it is the same thing. Okay.
That's good to keep hot dogs up.
Just cut it really fine. Yeah. Don't give it to them whole.
Don't change it, just cut it up.
Yep.
Sure is.
Yeah, anyway, right? Okay, so primary bronchi will branch into smaller diameter structures known as secondaries. Okay, they show you some secondaries over here. Notice that they branch another time. Those are called the tertiary bronchi. They can even branch a 4th time and form quaternary bronchi. But at any rate, at some point we're going to get out to the terminal endings of those branchings called bronchioles. And those bronchioles are lined with these little grape-like clusters called alveolar air sacs. So our whole goal here is to continue the branching process until we eventually get into those small air sacs where gas exchange can occur. Okay, so that takes us down here near the bottom of the page. Let's look under the bronchi at those hollow bullet points. You'll notice here that those bronchi are lined again with ciliated epithelium. Again, we're pushing that contaminated mucus up and out so we can cough it and get rid of it or swallow it. We are still looking at a lining of cartilage to keep these passageways open. Patent is the name for an open passageway, but I want to make a clarification here. Up here at the